Bitcoin, it's
Yeah.
kind of built on this idea of being this decentralized, really robust system.
Yeah.
And look, for over a decade now, it's largely delivered on that promise, right?
It has. It's shown remarkable resilience.
But, when you're talking about something with the kind of value, the kind of influence Bitcoin has, understanding the potential cracks, the vulnerabilities, well, it isn't just interesting, it's actually pretty crucial.
Exactly. That distributed nature, it offers incredible strength, for sure. But it also creates this unique landscape of potential weak points.
Yeah.
So we've looked at a whole range of sources for this, technical analyses, reports on real-world incidents, really trying to dig into what could actually potentially threaten Bitcoin.
Right. And forget the endless debates about, price predictions for a minute. Our mission today for this deep dive is really to cut through all that noise. We want to identify the most significant risks Bitcoin faces, maybe how these attacks could play out, and critically, what defenses are actually in place.
Yeah, what's protecting the network?
Exactly. We want to give you a clear understanding of the challenges, but without, drowning you in super technical jargon.
Keep it accessible.
Yeah. Okay, so let's start with something that can hit even the most well-defended online stuff. DDoS attacks. Distributed denial of service.
Right, DDoS. Think of it like a digital traffic jam, or maybe a flood.
A flood, okay.
Yeah, an attacker tries to overwhelm a target, maybe an exchange where you trade, or even the individual computers, the nodes that help run the Bitcoin network, just floods them with so much bogus traffic that they become slow or, totally unusable.
Okay, so the core Bitcoin network itself, the blockchain, it's super spread out, right? So you can't really DDoS that.
Well, not easily, no. It's incredibly distributed by design.
But these attacks go for the places where people actually interact with Bitcoin, the edges.
Precisely. The core protocol is designed to be extremely hard to take offline completely. So DDoS attacks, they aim for the choke points.
Choke points.
Like the exchanges you use to buy and sell. Or the full nodes that broadcast and verify transactions. It's kind of like trying to disrupt a global supply chain by just overwhelming the key ports in distribution hubs.
Okay, that makes sense.
And what's really concerning about these attacks, especially when they hit exchanges during big price swings.
Yeah, when everyone's trying to trade.
Exactly. It stops users from reacting to the market, which could, make losses worse. It shows a kind of subtle vulnerability more in the user experience layer, even if the core network itself is fine.
And we've definitely seen these kinds of attacks happen, haven't we? I mean, the sources we looked at mentioned some pretty concrete examples.
Oh, absolutely. Exchanges like Binance, Coinbase, they'd been hit during those high volatility periods, made it really hard for people to trade right when they needed to most.
Right.
And full nodes have been targeted too. Attackers trying to slow down transaction confirmations across the whole network. We're even seeing more DDoS attempts now aimed specifically at Lightning Network nodes.
Ah, the layer 2 solution?
Yeah, the thing designed to speed up Bitcoin transactions at lower fees. So even that's becoming a target.
And it's not just Bitcoin, right? I remember reading back in September 2021, Solana and Arbitrum. One different tech, I know. But still, they had outages from DDoS attacks.
That's right.
Then if you go way back, like Mt. Gox, that big early exchange.
Yeah, Mt. Gox. Infamous.
It got hammered by DDoS attacks between 2011 and 2013. Repeatedly. That must have played a part in its collapse.
It certainly didn't help, yeah. It contributed to the chaos.
And our sources mentioned a massive one just this January. An exchange got hit with over a terabit per second of junk traffic.
Wow, yeah. That's huge. Just shows how persistent this threat is, across the whole internet. And crypto is definitely not immune.
So it seems like a constant battle then.
It is. But Bitcoin's fundamental design, that decentralization, it does give it some built-in advantages for defense.
Okay, so how does Bitcoin and all the stuff around it defend against these digital floods?
Well, there are multiple layers. Rate limiting is a basic one, just restricting how much traffic one source can send.
Okay.
Nodes also use smarter ways to pick which other nodes they connect to, prioritizing reliable peers.
Right, better connections.
On layer 2, like the Lightning Network, there are often small fees for routing payments. That makes sending loads of spam traffic kind of costly.
Ah, an economic disincentive?
Exactly. And then there's just the sheer number of nodes, over 16,000 Bitcoin nodes spread all over the world.
Yeah, that global spread must make it really hard to knock them all out.
Incredibly hard. You can't overwhelm the entire network simultaneously very easily.
Okay. What else?
Well, individual services like exchanges, they have connection limits. The Bitcoin network itself has transaction fees that go up when the network is busy. That helps prioritize real transactions over spam.
The fee market, yeah.
Nodes also have sophisticated ways to manage the mempool. That's like the waiting list for transactions to stop it getting clogged up. And then, of course, lots of services use standard web security stuff. CDNs, load balancing, filtering transactions, specialized DDoS protection services.
So lots of tools in the toolbox.
Definitely. So DDoS is, an ongoing headache. But the way Bitcoin is built, plus the steps people take, it makes it a manageable risk, at least for the core network.
Okay, so that's disrupting access. But what about trying to actually, take control of Bitcoin? Let's talk about the big one, the 51% attack.
Ah, yes. The infamous 51% attack. Almost mythical.
Yeah. So for anyone who hasn't heard the term, what exactly are we talking about here?
Okay, so in simple terms, a 51% attack happens if one single entity, or maybe a group working together, manages to control more than 50% of Bitcoin's total mining hash rate.
Hash rate being the total computing power securing the network.
Exactly. All the computers crunching the numbers to validate transactions and create new blocks.
Right. And if someone did get that much control, what could they actually do? What's the real danger?
Well, the big fear is they could potentially reorganize recent parts of the blockchain, effectively reverse transactions that were already confirmed.
So double spending the same Bitcoin twice.
That's the classic example, yeah. They could also censor new transactions, basically stopping certain payments from ever getting into the blockchain.
Wow.
And maybe most fundamentally, it completely undermines Bitcoin's core promise, immutability. The whole idea that once a transaction is locked in, it can't be changed. A 51% attack shatters that.
That sounds incredibly bad. So what stops it? Why isn't someone always trying to pull this off?
The main deterrent, honestly, is economics. Just the sheer cost.
How much are we talking?
To get over 50% of Bitcoin's hash rate, you'd need a massive investment in specialized mining hardware. Plus, the ongoing cost of electricity would be astronomical. Billions of dollars, easily.
Okay, billions.
And here's the kicker. Even if you spent all that money and somehow succeeded, the attack itself would likely cause everyone to lose confidence in Bitcoin. The price would plummet.
So you spend billions to attack it, and in doing so, you make the very thing you control worthless.
Pretty much. It's a very powerful, self-regulating mechanism, at least for rational economic actors. Why destroy the value of the network you just spent a fortune to control?
Right. It seems economically irrational for most.
It is. However, the fact that smaller cryptocurrencies have been hit by 51% attacks shows the calculation changes depending on the network's size and value. And you could imagine scenarios, maybe less rational ones, like if mining gets super centralized geographically, or if a powerful state actor decided to interfere for non-economic reasons, then the cost might be less of a barrier.
So it's not impossible, just incredibly expensive and usually self-defeating, like a sort of digital MAGDI mutually assured destruction.
Yeah, there are some parallels, you could say that.
Has Bitcoin itself ever actually faced a successful 51% attack? Or you've come close?
Not a successful one on the main network, no. Yeah, there was a moment back in 2014, a mining pool called ghash.io got worryingly close.
Really? How close?
They briefly approached that 51% threshold. It definitely set off alarm bells in the community. Big discussions about decentralization followed.
What happened?
Well, they never actually crossed the line, and they publicly committed to taking steps to reduce their share of the network's hash rate. It was actually a good sign, showed the community was watching, and that miners themselves understood the danger.
And today, the scale of Bitcoin's hash rate is just immense, right? Hundreds of exahashes per second.
Yeah, it's staggering. The raw computational power involved now makes achieving a majority incredibly difficult and expensive. Plus, as you said, the miners are spread out globally.
That geographic distribution is key, too.
Absolutely. Another crucial barrier. But again, it's important to remember the context. Several smaller proof-of-work coins that use mining like Bitcoin, but have much less hash rate securing them.
Like which ones?
Things like Bitcoin Gold, Ethereum Classic Verge, Litecoin Cash.
Yeah.
They have suffered successful 51% attacks. It just proves the underlying vulnerability exists in proof of work. The cost to attack Bitcoin is just vastly higher than for those smaller networks.
So beyond just being enormous, what are the specific defenses Bitcoin relies on against this kind of takeover?
Well, maintaining that high degree of mining decentralization is number one. The more spread out the miners geographically and in terms of ownership, the harder it is for anyone to get control.
Okay.
Then there's the sheer cost we talked about and the economic disincentive, the
Yeah.
risk of destroying the value. Those are huge deterrents.
Mm-hmm.
And, other blockchains are exploring different ways to reach consensus, like proof of stake, which has a different set of trade-offs regarding this specific kind of attack.
Okay, so 51% attack. Very scary, but very hard and expensive to pull off on Bitcoin.
That's a fair summary. A constant background risk, but one the network is well defended against currently.
All right, so we've hit DDoS, we've hit 51% attacks. Let's shift gears a bit. What about sandwich attacks? That sounds
Mm-mm.
less threatening, more like lunch.
Huh. Yeah, the name is a bit misleading. It's actually a technique mainly seen in the world of decentralized finance, or DeFi, especially on platforms like Ethereum that have complex smart contracts and decentralized exchanges.
Okay, so not really a Bitcoin thing then.
Primarily, no. Not in its classic form. Let me explain what it is first.
What do you do?
So a sandwich attack is a form of minor extractable value, or MEV. An attacker spots a large pending trade in the mempool, say, someone trying to buy a lot of a token on a decentralized exchange.
Okay.
The attacker then quickly submits two transactions, one before the victim's trade, that's called front-running, buying the same token to push the price up slightly. Then the victim's trade goes through at that slightly worse price. And then the attacker immediately submits a second transaction after the victim's, selling the token they just bought, profiting from the price change they engineered.
Whoa, so they sandwich the victim's trade between their own buy and sell orders.
Exactly. They profit from the price slippage they created.
Nasty. But why is Bitcoin less vulnerable to this?
Mostly because of its simpler design. Bitcoin uses the UTXO model, unspent transaction outputs, which is different from Ethereum's account model. More importantly, Bitcoin doesn't have complex native decentralized exchanges or the kind of intricate smart contract interactions where these opportunities usually arise.
So no DeFi playground, no sandwich attacks.
Largely, yes. But that might not always be the case. There are potential future risks.
Oh, like what?
Well, think about things being built on top of or connected to Bitcoin. Cross-chain bridges that link Bitcoin to other blockchains.
Right, where DeFi does happen.
Exactly. New protocols aiming to bring more complex smart contract functionality to Bitcoin, like RGB.
Mm-hmm.
Even things like ordinals and inscriptions, which embed data on Bitcoin, could they create new kinds of interactions.
Mm-hmm.
And then there are second layer protocols like Lightning or Wrapped Bitcoin, WBTC, which is used heavily in DeFi on other chains. These could potentially introduce scenarios where similar front-running or sandwich-like tactics become possible in the Bitcoin ecosystem indirectly.
Okay, so maybe not a direct threat now, but something to watch as Bitcoin evolves.
Definitely. Even things like replace-by-fee transactions or complex multi-party transactions could, in theory, create opportunities for sophisticated attackers to manipulate transaction ordering or fees in ways that disadvantage others.
So even if it's less common on Bitcoin itself, what are the general ways people try to avoid these kinds of attacks, like on Ethereum?
Well, users can try to avoid predictable trading patterns. Using private mempools or transaction relay services can hide trades from attackers looking for opportunities.
Okay.
On decentralized exchanges, setting a low slippage tolerance limits how much the price can change before your trade fails. Breaking large trades into smaller chunks can also help.
Makes sense. Less attractive target.
Right. And there are even specialized MEV protection services emerging that try to route transactions in ways that avoid getting sandwiched.
Interesting. So defenses exist even if the problem is more prominent elsewhere for now.
Exactly. It's good to be aware of the concept, especially as Bitcoin's capabilities expand.
Okay. So we've looked at technical attacks, protocol level attacks, but Bitcoin also exists in the real world, right? Within a legal and political landscape. That brings us to regulatory threats, or what some sources call a modern 6102 attack.
Ah, yes, the 6102 reference. It's definitely an evocative term.
It sounds pretty ominous. What's the history there? Our sources link it back quite a way.
They do. It refers to U.S. Executive Order 6102. This is back in 1933, signed by President Franklin D. Roosevelt.
Okay, Great Depression era.
Right. And that order basically prohibited U.S. citizens from hoarding gold coin, gold bullion. They had to turn it in and sell it to the government at a fixed price.
They confiscated gold. Wow. Why?
The official reason was to combat hoarding during the economic crisis and allow the government to control the monetary system more effectively, strengthen the dollar, which was tied to gold then.
Okay. So applying that to Bitcoin, a 6102 attack is the fear that governments might try something similar, like restrict or confiscate Bitcoin.
Precisely. It's the concern about significant government or regulatory action aimed at controlling, limiting, or maybe even prohibiting the holding and use of Bitcoin.
How might that actually look? What kind of actions are we talking about?
Well, it could take several forms. Maybe mandating that all Bitcoin has to be held by regulated custodians, banks, exchanges, etc.
Taking away self-custody.
Potentially, yes. Or imposing really strict, maybe overly intrusive KYCMO, know your customer, anti-money laundering rules that severely compromise user privacy. We could also see governments trying to censor or outlaw tools that enhance privacy and self-custody, things like CoinJoin mixers or privacy-focused wallets like Wasabi, maybe even directly targeting non-custodial wallets themselves.
That sounds like a pretty direct assault on Bitcoin's core principles. Is there a difference between like an outright ban and this soft 6102 idea?
Yeah, that's a good distinction the sources make. A hard prohibition is straightforward, making it illegal to own or use Bitcoin.
Yeah.
Bam. A soft 6102 is maybe more subtle, more insidious. It's about creating an environment where self-custody becomes really difficult or legally risky or just super inconvenient.
Oh.
Maybe through tax disadvantages or making it hard for self-custodied coins to interact with the regulated financial system or just generally pushing people towards using approved custodians through sheer regulatory pressure or perceived safety.
So you're not banned from holding your own keys, but they make it so much easier or safer seeming to just let a big company hold it for you.
Exactly. And that could effectively achieve a similar outcome, undermining self-sovereignty and financial freedom, but without needing a politically difficult outright ban.
But hang on, Bitcoin is global, it's decentralized. How practical is it for any single government, even a powerful one, to actually enforce rules like that effectively?
That is the fundamental challenge for regulators, isn't it?
Yeah.
Bitcoin was designed to be borderless. It operates across this vast, distributed network of nodes everywhere,
Yeah.
completely shutting it down globally. That seems like a monumental, maybe impossible task. But governments can certainly impact how easily people access and use Bitcoin within their borders. They can regulate the centralized choke points, the exchanges, the on-ramps where fiat money turns into crypto.
The bridges to the traditional system.
Right. Enforcing rules against holding your own keys at a fundamental P2P level.
Yeah.
That's incredibly difficult to police globally. But they can make life difficult for those who do.
We have seen some pretty major actions, though, haven't we? Like China's big crackdown on Bitcoin mining in 2021. That must have been a test case.
It absolutely was a huge test.
What happened? Did it cripple the network?
It caused a massive rapid drop in Bitcoin's total hash rate. A huge chunk of the world's mining power just went offline almost overnight.
Wow.
But the network? It adapted remarkably well, actually. Bitcoin has this built-in feature called the difficulty adjustment. It automatically recalibrates how hard it is to mine new blocks based on the total hash rate. So when all that Chinese hash rate disappeared, the difficulty dropped significantly. That made it easier and more profitable for the remaining miners around the world to pick up the slack. New mining operations popped up elsewhere, in places like the US, Kazakhstan, Canada.
So the network just routed around the damage.
Pretty much. It really highlighted Bitcoin's anti-fragility, its ability to absorb a major shock and keep functioning, keep producing blocks roughly every 10 minutes.
Okay, that's pretty impressive resilience. So maybe a full-blown global 6102 confiscation is unlikely, but the risk of increasing regulatory pressure, especially on the big exchanges and custodians, that seems more real.
Exactly. Those large centralized pools of Bitcoin held by exchanges are much easier targets for potential government freezes, seizures, or restrictive regulations. And that really hammers home the importance of self-custody, doesn't it? Holding your own private keys is the primary way for individuals to maintain direct control and potentially resist those kinds of pressures.
So self-custody as the ultimate countermeasure.
It's a core part of the defense, yes. Along with Bitcoin's borderless design, the growing institutional adoption, which brings lobbyists and advocates, plus ongoing development of privacy tools like CoinJoin or PayJoin, and just the resilience of the underlying peer-to-peer network. They all contribute to Bitcoin's ability to navigate these regulatory headwinds.
Okay, so regulatory risk is definitely out there, maybe more of a soft pressure than a hard ban, but self-custody is key. All right, beyond these really big categories, DDoS, 51% regulatory stuff, our sources mention a bunch of other notable attack vectors, things that are much less common or more technical, but still worth knowing about.
Yeah, absolutely. There are quite a few other ways people have thought about potentially attacking or disrupting the network.
Let's touch on some of those. What about time warp attacks? That sounds sci-fi.
A little. It's basically an attempt to manipulate the timestamps that miners put on the blocks they create.
Why would they do that?
The goal is to try and trick the network's difficulty adjustment algorithm. If you could consistently mess with the timestamps, you might theoretically make the network think blocks are being found faster or slower than they really are, and manipulate the difficulty to your advantage, maybe making mining easier for yourself.
Can that actually work?
Bitcoin has defenses against it. There are rules about valid timestamp ranges, but it shows how attackers looked for ways to game even subtle assumptions built into the protocol.
Interesting. Okay, what about Sybil attacks? That term comes up a lot with decentralized systems.
Right. A Sybil attack is where an attacker creates a whole bunch of fake identities, or in Bitcoin's case, fake nodes on the network.
Like an army of sock puppets.
Kinda, yeah. The aim isn't usually to take over consensus directly in Bitcoin because node count doesn't equal voting power like hash rate does. But if you control enough fake nodes, you could potentially disrupt the network in other ways, like influencing how transactions or blocks get relayed, maybe isolating certain real nodes, or even trying to de-anonymize users by observing traffic from many points.
How is that mitigated?
Well, using privacy networks like Tor or I2P when connecting your node can help obscure your real location and connections. And just the natural diversity of well-connected, honest nodes makes it harder for Sybil nodes to gain significant influence over the whole network.
Okay. Then there are routing attacks. This sounds like it affects the internet itself, not just Bitcoin.
It does. This involves manipulating the internet's core routing system, the Border Gateway Protocol, BGP. It's like the internet's postal service, directing traffic.
And attackers can mess with that.
Yes. A sophisticated attacker, maybe a state-level actor or a compromised ISP, could potentially hijack IP address ranges used by Bitcoin nodes or miners.
To do what?
To intercept their traffic, maybe delay block propagation to certain parts of the network, or even partition the network temporarily. It's an attack on the underlying internet infrastructure that Bitcoin relies on.
Are there defenses against that?
It's a hard problem because it's fundamental to how the internet works. But there are efforts, like projects, to build more secure relay networks for Bitcoin traffic, like Saber, that try to make routing manipulation less effective.
Got it. Eclipse attacks sound kind of similar to Sybil, but maybe more targeted?
Exactly. An Eclipse attack aims to isolate one specific node, rather than flooding the whole network.
Wow.
By surrounding it. The attacker tries to make sure that all of the target node's connections are to nodes controlled by the attacker.
So the victim node only sees what the attacker wants it to see.
Precisely. They're a clips from the real network. The attacker could then feed it false information like a fake blockchain history to try and trick it into accepting a double-spent transaction, or maybe disrupt its mining if it's a mining node.
Nasty. How does Bitcoin defend against that?
The Bitcoin core software has countermeasures. It tries to ensure nodes connect to a diverse set of peers across different network ranges, making it much harder for an attacker to control all of a node's connections. Diversity of connections is key.
Okay. Now, looking further out, quantum computing. This comes up sometimes as an existential threat. Should we be worried?
It's definitely a long-term consideration, not an immediate threat today.
Why not?
Well, the theory is that a powerful enough quantum computer could potentially break the type of cryptography Bitcoin uses for securing transactions specifically, the elliptic curve digital signature algorithm, or ECDSA.
Breaking the encryption that protects private keys.
Essentially, yes. If you could break ECDSA quickly, you could potentially derive someone's private key from their public key and steal their funds.
Yikes. So why isn't everyone panicking?
Because building a quantum computer powerful enough, stable enough, and with low enough error rates to actually break Bitcoin's crypto, it's still considered years, probably decades away by most experts. It's a massive scientific and engineering challenge.
Okay. And is the Bitcoin community doing anything about it?
Oh, yes. There's active research and discussion around implementing quantum-resistant cryptographic algorithms, basically upgrading Bitcoin's crypto to new types that are believed to be secure even against future quantum computers.
So a potential future upgrade needed.
Right. And there's another interesting point. Bitcoin addresses where funds have been received but never spent from yet. They have an extra layer of protection.
How so?
Because the public key associated with that address isn't revealed on the blockchain until the first time you pen from it. The address itself is a hash of the public key. So for unused addresses, a quantum attacker wouldn't even have the public key to target initially.
Ah, okay. A little extra safety for HO dealers.
Kind of, yeah. But the long-term solution is likely migrating to quantum-resistant algorithms.
All right. What about selfish mining? That sounds like miners being greedy.
It is. It's a strategy where a miner or a pool finds a new block, but deliberately doesn't broadcast it to the rest of the network immediately.
Why would they hide it?
They start secretly trying to mine the next block on top of their hidden block. The idea is to build up a secret, longer chain. If they get lucky and find another block before the rest of the network finds one on the public chain, they suddenly release their longer secret chain.
And because it's longer, the network accepts it.
Typically, yes. The longest valid chain wins. This would invalidate the block found by the honest miners in the meantime.
So the selfish miner gets multiple block rewards, and the honest miners waste their effort.
That's a potential payoff, yes. Gaining an unfair share of the rewards.
Can this actually work effectively?
It requires a pretty significant chunk of the total hash rate to be consistently profitable. Estimates often say 25% or more. Below that, the chances of successfully pulling it off frequently are low. Plus, protocol improvements over the years, like headers first, block propagation, make it harder. Nodes get notified about new block headers very quickly, reducing the time window for a selfish miner to build their secret chain unnoticed.
And the economics again?
Yeah, the general economic incentives in Bitcoin still strongly favor honest mining and cooperating with the network. Trying to pull off selfish mining is risky and might not even be profitable in the long run compared to just mining honestly.
Okay. One last category. Social attacks. This feels different. Less technical, more human.
Absolutely. And maybe the hardest to quantify or defend against technologically.
What falls under social attacks?
It can be broad. Think about coordinated disinformation campaigns spreading fear, uncertainty, and doubt, or FUD to damage Bitcoin's reputation or manipulate the price.
Right, happens all the time online.
Exactly. It can also involve attempts to create deep divisions within the Bitcoin community itself, pushing contentious changes that lead to splits or hard forks like what happened with Bitcoin Cash.
Yeah, those forks can be messy.
They can dilute the network effect, confuse users, and create conflict. So Bitcoin's community, its users, developers, miners, is a huge strength. It's what gives it consensus and value. But that social layer can also be a vulnerability, a target for manipulation or division.
Wow. Okay, that is a really comprehensive rundown of the potential threats. DDoS, 51%, regulatory pressure, sandwich attacks, time warps, Sybils, routing, eclipse, quantum, selfish mining, social attacks. It's almost overwhelming.
It can definitely sound like a scary list when you lay it all out.
Yeah, it makes you want to triple check your security.
And it's not a bad instinct, but it's also really important to zoom out a bit. Remember, Bitcoin has been live, operating 24/7 for well over a decade now.
True.
And during that time, it has faced and survived numerous real-world challenges and various attempts to attack or disrupt it. This deep dive into the risks, it actually highlights something really crucial about Bitcoin.
What's that?
It's anti-fragility. It's not just robust, meaning it resists shocks. It's arguably anti-fragile. It often learns from attacks, adapts, and potentially gets stronger or more resilient as a result.
Okay, so the key takeaway isn't just hear all the scary things, but something more.
Yeah, I think the crucial point is understanding that Bitcoin security isn't just one thing. It's this complex, multi-layered model.
Layers.
You've got the strong cryptography at the base. Then you have the powerful economic incentives, the game theory that encourages honest participation.
Right, the cost of attacking versus the reward.
Exactly. Then there's the physical decentralization, all those nodes and miners spread globally. And finally, there's the social consensus layer, the agreement among users and developers about the rules of the network.
So it's a combination of tech, economics, and people.
Precisely. No system is ever going to be absolutely impenetrable. New threats will emerge, guaranteed. But Bitcoin's track record so far, and its ongoing development, suggests a security model that's proven remarkably adaptable and resilient over time.
So the message isn't necessarily, Bitcoin is invincible, but maybe more like Bitcoin has shown an incredible ability to withstand a whole lot of different threats.
That's a much better way to put it, yeah. And understanding these risks, knowing what they are, it actually empowers you as a user.
Awesome.
It helps you make more informed choices about how you interact with the network, how you choose to secure your own Bitcoin, whether you run a node, what tools you use. Knowledge reduces fear.
That makes sense. All right, well, as we wrap up this deep dive, maybe here's a final thought for you, the listener, to mull over. Reflecting on everything we've discussed today, all these different potential risks, from DDoS to quantum computing to regulation, What specific aspect of Bitcoin's security model do you personally find the most reassuring? Or maybe on the flip side, what worries you the most for its long-term future?
Yeah, is it the core tech you trust most?
Yeah.
The economic incentives? Or are you more concerned about those external factors like government actions or social divisions?
It's really about considering that balance, isn't it, between the technical strengths and those maybe less predictable human and political elements?
Definitely food for thought.
And maybe thinking about that balance might even inspire you to dig deeper into some of these areas yourself. Perhaps look into what it takes to run your own full node, or explore some of the privacy-enhancing tools we mentioned.
Always more to learn.
Absolutely. Well, thanks for joining us for this deep dive into Bitcoin's security landscape.